This video briefly describes some of the work of the Japanese physicist Dr. Tadahiko Mizuno with plasma electrolysis. This experiment involves a cell containing a tungsten electrode and a ground anode immersed in a water solution. Around 200 volts is applied across the tungsten electrode and the ground anode connections. This produces a sort of bubble of plasma around the tungsten electrode. Shown here is Dr. Mizuno's laboratory setup. Using colorimetry, an over-unity factor in excess of 100 was often observed. That is, at least 100 times more energy would be produced by the experiment than the amount of energy that was fed into the experiment. However, it was not always that stable. At one point, the factor spiked and was estimated to have exceeded 800. The cell chamber burst apart as a result. Perhaps industrial-scale power generation with plasma electrolysis would not be very safe. Dr. Mizuno's laboratory had a scanning electron microscope. This enabled use of an energy-dispersive X-ray or EDX spectrometer. Elemental analysis could be done on the surface of the tungsten electrode. Shown here is the EDX spectrograph of tungsten metal. After the experiment, trace amounts of other elements are detected on the surface of the tungsten electrode. Dr. Akito Takahashi has suggested the three naturally occurring isotopes of tungsten: tungsten 182, tungsten 184, and tungsten 186 were breaking down into smaller nuclei. These reactions are shown here along with calculated yield values. For comparison, most fission reactions involving uranium-235 yield about 200 million electron volts, or MeV. Thus, it seems possible that a gas or plasma produced by electrolysis of water mediates some sort of low-energy nuclear reaction. It would seem that this involves some sort of physics that is not well understood. Therefore, mainstream science tends to be a bit dismissive of this result. Nevertheless, investigation into these effects of this type continues. Thanks for watching.